Let's consider the following limit. Let's take the limit as x approaches 0 of x squared cosine x. Now this is interesting because let's evaluate at the point 0. Okay, so at 0, cosine of x is 1, but x squared is 0. So how do we resolve this? Yeah, there's some different ways. You could consider plugging in values, and you could even analyze what the functions do as it gets very close to 0. But what we're going to do is we're going to use the squeeze theorem to basically prove that it does equal 0. So we are going to prove that this equals 0. Now, when we do this proof, I'm just going to write down the key steps. So if you actually had to prove something, you might want to include some of the words that I'm saying. Okay, so how do we do this? So to use the squeeze theorem, the key is to take, it's usually a trig function, to take your trig function and bound it. So the cosine of x is bounded between 1 and negative 1. Okay, so that's the first step, right? Like, you should know that from trigonometry. Now, we need to get x squared in there. So when you have an inequality, you can multiply each side of the inequality by x squared. Note that x squared is positive, so it's not going to be changing the direction of the inequalities. If you multiply by a negative number, that does change the direction of the inequality. So it's still true that negative x squared is less than or equal to x squared cosine x, which is less than or equal to x squared. Okay, great. What next? We want to get the limit as x goes to 0. So just like you can do the same thing to both sides of an inequality in terms of multiplication, we just multiply by x squared, you can also take the limit of each side of an inequality. Okay, so we can actually do the limit as x approaches 0 of negative x squared is less than or equal to the limit as x approaches 0 of x squared cosine x, which is less than or equal to the limit as x approaches 0 of x squared. So taken all together, what we have here, it should be clear on the left side. Negative x squared, as x goes to 0, you can plug it in, it's continuous, it's just 0. So you've got a 0 here. Let's go ahead and leave in the middle, which is what we're trying to figure out. So this limit as x goes to 0 of x squared cosine x. And on the right side, we also get 0, right? Because x squared is continuous, you plug it in, you get 0. Okay, so what we have a limit between 0 and 0, okay? It doesn't matter what the expression is in the middle here. The only number between 0 and 0 is 0. So by the squeeze theorem, okay, by the squeeze theorem, we call it the squeeze because it's like you're squeezing it in between two other limits. You can conclude that the limit as x goes to 0 of x squared cosine x is in fact 0. Okay, so key with the squeeze theorem is really starting it. You know, bound the trig function, cosine of could be of whatever. It's going to be between negative 1 and 1, right? If you had a 2 in front of there, it'd be between 2 and negative 2, okay? And then, generally speaking, you multiply through. And the goal of the squeeze theorem really is to find an inequality where you can easily compute the left and the right side, and then the piece in the middle has to be between them. Okay, let's do one other sort of fun example using intermediate value theorem. So what we're going to do now, we're going to prove that the square root of 2 exists using, I think it's fine to call it the IVT. intermediate value theorem. Okay, so you gotta know what the intermediate value theorem is. What does it tell you? It tells you that if you have a continuous function, okay, and you have like a lower bound and an upper bound of that function, and there's some value in the middle, there must be like something in the function that equals that value. So I think this example will hopefully make it clear. Now, it might not be obvious how to start something like this. You generally want to have equations, and you want continuous equations for the intermediate value theorem. It highly depends on continuity. It doesn't work without continuity. And so the way you can get root 2 out of an equation is, we could say something like let f of x equal, what's our function going to be? How about x squared minus 2? Okay, so the idea here is that x squared minus 2 can deliver the square root of 2. When does it deliver it? When it's equal to 0. Okay, so the strategy for the intermediate value theorem is to find then, not 0, a number greater than 0 and a number less than 0. But the intermediate value theorem, okay, I was going to put a sketch up here, but if you're going through 0, I think we'll go ahead and do it. So this is our function. So x squared minus 2, it means like it starts down here instead of at 0. And it goes up. Okay. So we have a continuous function here, and it crosses y equals 0. That means there must be some value there that equals 0. Okay? So all we need to do is to state a value less than 0 and a value greater than 0, and by the intermediate value theorem, it must go through 0. Okay, so let's consider, how about, okay, so what do we have? Let's do our steps. 1, let's take f of 1 equals 1 squared is 1 minus 2 is negative 1. And then number 2, we've got f of 2, because we want to get a positive 1 now, we get 2 squared, 4 minus 2 is 2. Okay, now you always got to say it's continuous, so since f is continuous, by the intermediate value theorem, what do we have? There must be some value, okay? So I'm going to use, it means there exists, and it's going to be some number, we know what it is. So there exists, say, an x, that's a member of the real numbers. You don't need to know all this math notation, I'm just trying to put some shorthand up. So there exists an x in the real numbers such that what? Such that f of x equals 0. And if f of x equals 0, okay, you can put a little conclusion up here. Thus, x squared minus 2 equals 0, or x squared equals 2 as a solution. Okay, that proves that root 2 exists.